Without water, no life is possible. It shapes our societies, daily lives, and future. But now, more than ever, it's becoming a major concern for humanity. More frequent droughts and constantly rising demand are making freshwater, a common resource, increasingly scarce.
This water here is a precious treasure. It has met our needs for centuries, but unfortunately that's no longer the case.
It's estimated that by 2050, half of the world's population could have difficulty accessing drinking water. As a result, all eyes are on the seemingly abundant water of our oceans. Removing salt from the sea to obtain fresh water is a promising solution that's making waves worldwide. Desalination. The Spanish archipelago of the Canary Islands off the coast of Africa was the first European region to introduce this method more than 60 years ago.
We don't have enough fresh water for the over 2 million residents and 15 million tourists every year. So how else do we get this fresh water? We take it from the sea, remove the salt, and produce it ourselves.
For these islands, plagued by severe droughts, this technology was a blessing.
Turn on the tap and the water flows. For us, it's wonderful.
We can't manage without the desalination plants anymore.
But the illusion of abundance drove an unrestrained and very water-oriented economy, the latent effects of which are ticking time bombs.
Desalination allows us to survive, but it consumes oil and produces waste.
For research into the possibilities and limitations of desalinated water, the Canary Islands serves as a large, open-air experiment. The Canary Islands are roughly 1,200 kilometers southwest of the Iberian Peninsula and are one of the EU's most arid regions. As rainfall here is much less than the Spanish average, inhabitants have always prioritized the search for water. And the forest plays a crucial role here. On the peaks of El Hierro, declared a biosphere reserve by UNESCO, are what's left of forests that covered Europe millions of years ago.
These laurel forests, made up of laurel and other trees with similar leaves, are confined to a small area of the island and condense rain on their leaves. Many years ago, this was an important way for the local population to access water, which is precious on an island like this one that often suffers from drought.
The water comes from vapor that's produced when seawater evaporates. Tiny droplets form dense clouds. These envelop the forest and leave their precious moisture on the leaves of the trees.
What we're looking at here is something we call the Sea of Clouds. Up close, you can see that the leaves of the laurel trees are covered with moisture and droplets. We call this phenomenon horizontal rain. The mist, the humidity around us, condenses on the leaves and falls to the ground as droplets. And this fills our groundwater aquifers.
Even the indigenous people of Tenerife, who settled here 2,000 years ago, collected fog water in basins carved into the rocks. Centuries later, as the population grew, numerous wells were drilled to harness the water that had seeped into the ground. From the 1850s onwards, tunnels known as galerías were dug all over the islands to access the precious groundwater. Over 1,700 kilometers of tunnels have been dug beneath the Teide volcano on Tenerife. Jaime Coello Bravo, who grew up here, ventures deep into the heart of the island in search of this precious resource.
This is a very special place for us Canarians. It's like entering a cathedral of water.
This galería extends over 5 kilometers to what's known as the phreatic zone, into the water table. The water flows along the walls to the ground, where it then drips down to a canal.
The galerías are a poignant sight because they symbolize the Canary Islands' struggle against water scarcity and the huge effort needed to obtain even just a tiny amount. As you can see here, it's clear that the smallest drop counts and that every single one is needed to supply the population with drinking water. I regularly check whether stones or branches have gotten trapped in the canals. We have to make sure the water reaches people's homes without any issues.
Up to 80% of the drinking water on Tenerife comes from wells and tunnels, so they must be meticulously monitored.
I'm checking the water level in the galería to see if it's stable or going down. We're now seeing a significant decrease because there's less rain.
Climate change and declining rainfall are exacerbating water scarcity. Juan Ramon was born on the island of El Hierro and remembers one of the archipelago's worst droughts. Today, he returns to the place of his childhood, where fresh water was transported by donkeys along kilometers of steep paths.
Back then, I was 14 or 15 years old. I helped my parents on the property with the animals, the wine, and the potatoes. And whenever we needed water, we took the donkey down to the well. The well was at the foot of the cliff.
Starting in 1947, El Hierro suffered 3 consecutive years of severe drought. Poverty and hunger prevailed on the island.
We had nothing. Nothing to eat, nothing to drink, nothing at all. The animals died. The goats and the sheep. It was a terrible, terrible drought. I hope nothing like that ever happens again. People sailed away in their boats. They said, before I die of starvation, I'd rather risk the crossing. I went too.
In 1948, Juan Ramon, like many other inhabitants of the Canary Islands, boarded an illegal ship bound for South America. He spent decades in Venezuela, but has since returned home. Memories of the drought have stayed with him to this day.
It's a miracle for us. Even if the water comes from the desalination plant, you turn on the tap and you have as much water as you want.
In 1964, Europe's first desalination plant was delivered to the Canary Islands. Lanzarote, the most desert-like island in the archipelago, was the first to start desalination. Its water supplies were under severe pressure due to prolonged periods of drought. But this new technology was extremely rare at the time. The plant was based on a model by a small group of visionary entrepreneurs from the US. For the first time, European citizens owed their survival to desalinated water. The technology spread rapidly to neighboring islands. But it wasn't until the 1990s, when the process was modernized, that desalination experienced an exponential boom. Today, the Canary Islands have some of the most desalination plants per square kilometer in the world, with 330 public and private facilities. More than 20,000 of these plants are in operation around the world. Even though they don't cover basic consumption by a long shot, more than 300 million people depend on them. Tenerife is home to one of the largest modern desalination plants in the Canary Islands. It supplies the entire north of the island. Juan Ayala Barroso is head of operations.
Our plant treats around 30,000 cubic meters of water every day, which is equivalent to around 15 Olympic swimming pools. For the city of Santa Cruz de Tenerife, this represents approximately 60% of its water consumption. The remaining 40% comes from wells or galerías.
The water pumped from the sea is initially purified using a series of microfilters.
We're at the heart of the plant here. We use a process called reverse osmosis to make fresh water.
Reverse osmosis uses water pressure to remove salt and minerals from the water. The seawater is injected through a series of tubes and forced against the walls of a semi-permeable membrane under high pressure. While some of the water molecules pass through the filter's nanoscopic pores, the rest of it remains behind, along with the salt and its minerals. On average, for every 100 liters of seawater, 45 liters of freshwater and 55 liters of very salty brine are created.
The water is drinkable now, but not ready for distribution. It needs to be remineralized and disinfected first.
But although the tap water is drinkable, many people choose not to drink it. Due to its taste, smell, and reservations concerning its processing, most Canarians prefer to drink bottled water imported from the mainland. So, what's the desalinated water for then? In addition to its household uses, it primarily supplies the country's most important industry, tourism. Desalinated water offers endless possibilities. For example, watering the 23 golf courses or operating the archipelago's countless hotel swimming pools. But how did things get so bad in the first place? After the Second World War, dictator Franco's Spain was a nation on its knees. enduring 20 years of economic hardship. But in the 1960s, an increase in paid vacations and the expansion of air travel presented new opportunities. Desalination now became a way to save the island's economies by transforming them into popular seaside resorts.
Ici, dans tous ces endroits où il y a maintenant les hôtels et les appartements, je crois qu'il n'y avait absolument aucun immeuble il y a 10 ans.
C'est ça, justement.
Il y avait quoi?
Il y avait des plantations de bananiers. Tout ça était des bananiers.
Il y avait combien de touristes ici il y a 5 ans?
Il y a 5 ans, nous avions seulement que 3 000 touristes.
Et l'année dernière?
L'année dernière, nous avons eu 45 000.
Today, around 17 million people visit the archipelago every year. Jaime Coelho Bravo witnessed the tourism boom.
Before the 1960s, there was nothing here. Now there's a shopping mall, an artificial beach, and even buildings that are built into the volcanic crater. All this was only made possible by desalination. It's like an amusement park here, with fountains and Roman temples. This has nothing to do with our islands. It's all because tourism accounts for 75% of our GDP.
However, to produce desalinated water, the islands depend on fossil fuels imported from the mainland. But this water also nourishes another important economic sector: agriculture. On Tenerife and most of the islands in the archipelago, there are banana fields as far as the eye can see.
This plantation has around 5,000 banana trees. Each one needs about 20 liters of water a day.
Banana cultivation, introduced by the Portuguese in the 15th century, initially developed with the help of natural water resources. However, repeated periods of drought, outdated irrigation systems, and the massive expansion of banana farming led growers to switch to desalinated water.
The wells yield less and less water. There's no longer enough for all the plantations. So we have to resort to desalinated water.
However, water that's dependent on the price of oil means additional costs.
Today we're under pressure from unfair competition from bananas from South America, where regulations aren't so strict. We've got high labor and water costs. Production is expensive, and bananas from South America cost half as much as ours from the Canary Islands.
Government subsidies and desalinated water are keeping banana cultivation alive here. 400,000 tons are grown each year across the archipelago, mostly for the export market. Within 60 years, desalination has become the cornerstone of the Canary Islands economy. The exception is La Gomera, which mostly manages with its available natural freshwater resources, while all the other islands rely on treated seawater. Lanzarote and Fuerteventura as much as 100%. More than 500,000 cubic meters of water are desalinated daily across the archipelago, an extremely energy-intensive process.
The production and distribution of desalinated water is still almost entirely dependent on electrical energy.
The desalination process alone consumes more than 10% of the electricity generated on the islands. Most of the energy comes from thermal power stations continuously burning oil and gas imported from the mainland. The energy requirements for the plant in Santa Cruz alone are enormous.
30,000 cubic meters of desalinated water consume around 100,000 kilowatts of electricity per day.
The weekly electricity consumption of the archipelago's 330 desalination plants is equivalent to the cargo of a 120,000-ton oil tanker. The carbon footprint of desalination in the Canary Islands is huge. Every day, up to 2,000 tons of carbon dioxide are released into the atmosphere. This is comparable to 8,500 cars with combustion engines driving around 2,000 kilometers every day. Plant operators are aware of this dependence on fossil fuels. For several years now, they've been trying to generate their own energy. El Hierro, the smallest island in the Spanish archipelago, is striving for energy self-sufficiency by using renewables. The 11,000 residents and 20,000 tourists who come every year are supplied with water by 3 desalination plants. One of them resembles a church.
El Hierro has, in my opinion, taken an unprecedented decision to focus on renewable energies. The Corona del Viento hydroelectric power station is the first of its kind in the world and enables the production of large volumes of renewable energy. This green energy is fed into the system so that we can use it to desalinate water at a much lower cost.
The Corona del Viento hydro wind plant is often held up as a model. 5 wind turbines with a maximum output of 11.5 megawatts supply the island with electricity. The system's innovation lies in the fact that, like some hydroelectric dams, surplus energy is used to pump water from a lower basin to a higher one on the island. When the wind dies down, the water stored above is released to drive hydroelectric turbines, which means a steady supply of green electricity. The process is sophisticated and appears to function exceptionally well. But if there's no wind, how long does the energy last?
It ranges between 20 and 45 days. As the wind doesn't blow constantly, it's not always possible to produce 100% renewable energy. That's when we compensate with fossil fuels.
Despite its efforts and ambition to become a global model for self-sufficiency in renewable energy, the island of El Hierro still can't manage without its diesel power plant. In fact, the Corona del Viento power station produces only 40% of the island's electricity. That means 60% of the energy, including for desalination, still comes from fossil fuels. But CO2 emissions aren't the only environmental impact of desalination. Another invisible form of pollution is threatening the oceans. This is because the reverse osmosis desalination process leaves behind almost the same amount of liquid waste in the form of a hyper-concentrated brine. This is returned directly to the ocean, the danger of which to the marine environment is often downplayed by the desalination industry. But not everyone shares this view. On the island of Lanzarote, fishers in the small harbor of La Santa are sustained by the fruits of the sea.
That's a triggerfish. That's a pigfish. I've been working here in the Canary Islands as a fisherman at sea for almost 40 years. Are they biting?
On his daily trips along the coast, Wenceslao Olivero Martin sees the effects of the brine on the sea.
If you pour a highly concentrated brine like that into the water, any nearby octopus just swims away.
There are plans to build a desalination plant close to the harbor.
They want to build it up there, maybe a kilometer from here. And then lay a pipe 19 or 20 meters into the sea, all the way to the bottom, for the brine to drain away. But that's pure poison for the sea. They can't.
The Canary Islands are home to one of the EU's largest marine reserves. This ecosystem is now threatened by brine from desalination plants. Experienced diver Fernando Espino has been studying the impact on marine biodiversity for over 20 years.
Hola Álvaro. Buenos días. ¿Qué tal? ¿Cómo estás? Muy bien, ¿y tú qué tal? Bien, aquí estamos. Vamos a ir a coger unas muestras afuera.
He and other oceanographers are warning of the devastating effects of the wastewater. Today, he plans to investigate the desalination emissions of hotel facilities in the most touristy part of Gran Canaria.
Most hotels use water from public desalination plants, but some also desalinate their own water because it's cheaper than water from the public network. The problem is, this means brine discharges scattered along the coast. This can lead to even greater pollution and is more difficult to monitor.
Reverse osmosis microstations are easy to install and an increasingly attractive prospect for hotels. They can keep things running, even in the driest areas.
Okay, let's follow the coordinates.
Yes.
Then we'll find the spot. We're almost there.
Yes. Just about arriving now.
Okay. Perfect. 18 meters. Here it is.
At a depth of 20 meters, brine flows continuously from a drain pipe into the sea. Fernando Espino captures images that document the progression of the damage over time. The facts speak for themselves. There's no flora or fauna within a radius of more than 50 meters around the drain. He then takes samples of the brine. This allows him to analyze the salt content and detect any chemicals that may be present. He discovers a dark area near the discharge point. It's a cyanobacterium, Lingbia majuscula. The biologist often finds it in areas where brine is discharged. This invasive species displaces all other life forms, in particular destroying the seagrass beds that usually cover the ocean floor along the coast. These underwater meadows are a refuge, food source, and breeding ground for fish. They're present in all the world's oceans and support a significant proportion of marine biodiversity. They capture light, produce oxygen through photosynthesis, and bind up to 15% of the carbon absorbed by the ocean worldwide. They grow at depths of 5 to 30 meters, or, in other words, the point where the discharged brine flows into the sea. After the dive, Fernando Espino examines the samples taken in his laboratory.
The salt content is around 60 grams per litre, almost twice as high as the usual value in the Canary Islands, which is otherwise around 36 or 37 grams per litre. The problem with this salt concentration is that marine organisms living on the seabed are adapted to much lower salt levels, and that ultimately means these organisms die. Algae, marine plants, invertebrates, even fish are affected when brine spreads across the seabed.
And that's not all. In addition to its toxic salt concentration, the brine also contains poisonous chemicals that are used to clean the pipes in the desalination plants.
The most commonly used chemical is the infamous sodium metabisulfite. It kills all aerobic life, that is, life that requires oxygen. It's been observed that in areas where sodium metabisulfite is released, fish die very quickly as a result of anoxia.
The chemicals and high salt concentration are killing marine flora. This not only destroys the habitat of a wide variety of species, but also an important carbon sink for the planet. The biologists' data is added to those studies that have been conducted since 2009 by other experts in the Red Sea, Florida, and Australia. They all show how serious the long-term effects of these substances are when they enter the oceans.
If these discharges of brine into the sea aren't properly investigated, analysed and prevented, they'll damage important marine ecosystems that we need in the fight against climate change, because they bind CO2 from the water. The destruction of these sensitive ecosystems via brine discharge is making climate change worse.
Vast volumes of brine flow into the world's coastal waters every day. In 2023, 51 billion cubic meters of this waste product were discharged into the oceans. Marine pollution, CO2 emissions, energy dependency. Desalination is problematic on many counts. Of the 7 islands in the archipelago, until 2024, only one has managed to do without it, La Gomera. The island of La Gomera is largely self-sufficient in water. This is partly because it has retained traditional water management practices. Water for human consumption comes from wells. For agriculture, most of it comes from reservoirs. Juan Luis Mora is responsible for sustainable water management in the north of the island.
La Gomera has 20,000 inhabitants, and our aim is to build the infrastructure necessary to meet their needs, and not much more. The island couldn't absorb 10 million tourists a year. Our accommodation and service capacities are limited, and we're trying to maintain current levels. We want to offer tourism that's sustainable for nature, and leave mass tourism to others. Whether they're a local or a tourist, each person here consumes between 80 and 100 liters a day. That's a reasonable amount that doesn't require desalination.
100 liters per day is on average considerably less than the per capita consumption on the other islands.
I've got water.
On La Gomera, you adapt to the circumstances.
The water's here.
Iru, there's water.
That also applies to agriculture.
The neighbors just told us there's water. We always have to be ready, because we rarely get water, maybe twice a month, and you never know exactly when. I just told Hugo with my whistle that there's water, and it's time to turn on the taps.
We use it to water the plants and fill the tanks. We only get it every 2 or 3 weeks. And how much or how little depends on the reservoir. But when we have water, that's great.
Water from the rare winter rains is collected by numerous dams. These are connected by pipes, forming a network that's unique in the world. It's a sophisticated system that distributes water resources evenly across all the island's agricultural zones.
It's an ancient distribution system, and it works perfectly. Farmers adapt their cultivation to water availability. They plant only vegetables in winter and fruit in summer. They space out watering depending on what's available. And sometimes they water as little as once every 20 days in this area to eke out reservoir supplies.
It's not like on mainland Europe, where you turn on the tap whenever you want to water. For example, we work with mulch to retain moisture in the soil. And we produce our own drought-resistant seeds.
On their 3,000 square meters of land, Irawutsa and Hugo adapt to the island's conditions and climate with ingenuity and frugality.
I think we're in a very sensitive area, where climate change is noticeable. It's already upon us. I see there's less rainfall. We all know and are talking about it. It's worrying.
We see desalination plants as an emergency solution to fall back on when required. At the moment, there's no need to provide desalinated water for agriculture. It's particularly important to maintain water supplies in summer months, for tourism at least. We're talking about small desalination plants from 1,000 to a maximum of 3,000 cubic meters per day, to be operated only when there's a shortage.
Meanwhile, on the other islands, desalination plants run 24/7. Alternatives are needed to limit the impact of desalination, as water obtained in this way has now become indispensable. At the University of La Laguna, Luisa Vera and her team are researching ways to recycle water from cities and seaside resorts. Their goal? To reduce the consumption of desalinated water in agriculture.
In the Canary Islands, we need water to sustain agriculture. It must be high-quality water because we have very demanding crops, such as bananas. We believe that membrane bioreactors will help us obtain optimal water to produce a fertilizer or biostimulant, allowing us to work more sustainably and independently of external sources.
Membrane bioreactors developed by Luisa Vera's research team were installed at the sewage works in northern Tenerife in 2018. The wastewater is directed into large basins and converted into nutrients with the help of microorganisms.
Here, bacteria absorb the oxygen contained in the air and breathe like we do. They feed on this organic matter and convert it into biomass.
As they feed on the gray water pollutants, the bacteria grow and can no longer penetrate the pores of the membranes in the tanks.
The membranes are right here under my feet. Ultrafiltration membranes with a pore size of 0.04 micrometers. It's at this size where the magic happens.
Now, the recycled filtered water only contains fertilizers useful for agriculture, such as nitrogen, phosphorus, and potassium. It's also cheaper than desalinated water, so more farmers are using it, and thereby significantly reducing desalinated water consumption. As global freshwater supplies come under accelerated pressure, desalination and water recycling are becoming more crucial than ever. But are these energy-intensive technologies the only solution?
The situation must change. And in fact, many initiatives are already underway in the fields of research and innovation, covering all aspects of decarbonization in these facilities, aimed at minimizing energy dependence.
For me, desalination is just another tool. But it's not magic. We cannot develop a mentality that water is unlimited and infinite.
There's no point in giant projects like desalination plants if we don't change our outlook and our approach to water.